Basically, what we are going to do now is going to go over the basics of NoSQL, what NoSQL is, how is it different from a traditional RDBMS system, and what are the main differences between them. So, what is NoSQL? NoSQL is basically not only SQL, does not use SQL as a querying language. It's not basically structured around using SQL to query data out of a data store. It's more of a document-oriented database where we actually store documents, and all the data is structured in the forms of documents. It's not structured in form of relations and tables. So it's distributed, fault-tolerant. No fixed schema. It doesn't follow any schema at all. Basically, we generally use JSON notation for storing data in those documents, and we can add or remove fields as we wish. Like along the way we are storing some information, and along the way we feel that there is some kind of information that was left out in the initial documents. Like for instance, we are creating a user logging, we are actually logging users login and logout details, and we didn't add in time stamp, or we didn't add date stamp. So we can do that along the way as we are going forward. In traditional SQL, we need to have a structure. We need to have it there when the database was, when the table was created actually, right? So this doesn't follow any kind of a schema. The schema can be modified, the schema can be changed whenever required. Further, there are no joins. This is the main reason for using an RDBMS. We require joins to actually, basically when we normalize a database, for collecting data, we need to join multiple entities together to get a proper result out of it, right? So we don't have any joins in NoSQL databases. Basically, we can structure a single document to store all the information, or we can divide them into multiple documents as well. But the most relevant way, and the way we are actually using it in one of our own projects, we are storing all the relevant information. For instance, like if we are storing a user, we are using users login details, logout details, usage history. Everything that is related to a single user is stored in a single document. So it eliminates the need for dividing it into multiple entities. Thus, it's just a single database call that gives me back my whole user instance or my whole user entity for a specific user.
In that case, you will be having a lot of redundant information?
No.
If you take the example, very simple example of student and courses, what I understand that you will be having all your courses and course information into a pile of a student.
No, we can just have the student, the courses that are related to one student in that relevant document, or we can actually divide it in the same way as we do for our RDBMSs. You know, to remove redundancy, what we usually do is we divide them into two separate entities, right? But we don't actually need that over here. We can have a separate courses entity, and we can cross-reference keys, but then we will be going back into the same problem that NoSQL eliminates. We'll be actually creating joins, virtual joins, you know, fetching a student, then going back to the courses and fetching each course by a key, or maybe creating a many-to-many entity, and then going to the many-to-many entity, getting all the keys, and then going back to the courses. Now, to eliminate this, what we actually do is we are structuring them in a single document. It's like when you go for shopping and you get an invoice, right? That invoice document on its own is can be used as a reference for the document that we store in a NoSQL database. It's going to be the same document. We'll have a customer name, date of purchase, the products that were sold to him, and everything that single document contains. But what that will do for us is it will actually, whenever I need to query my single customer, I'll have everything related to that customer from a single document, instead of making multiple database calls. You know, that eliminates the need for the bandwidth that we actually use for making multiple calls. The application keeps on waiting, and furthermore, we actually can use MapReduce. It's not part of this thing, but we do that to, you know, aggregate, collect data, aggregate it in some format and send it back to the user. So coming back to the presentation, why we don't use joins that are traditional to RDBMS? The reason is expensive operation for combining records from 2 or more tables into one set. Joins require strong consistency and fixed schemas. We don't have fixed schemas in NoSQL databases. So that's the main reason that we can't use joins over here. We can actually create virtual joins, but that will be programmatic joins on their own. And this goes in the benefit of NoSQL database, because as we don't have a fixed structure, we don't use joins. It's very flexible, and this helps us in situations where RDBMS is not suitable, right? It's not, and then in the end, it's not a replacement for an RDBMS. It basically complements it. We can't compare it in terms of like is one better than the other. It's like two different set of tools which are going to be used for a different scenario. We can't actually replace the structure that the RDBMS gives us. We have transactions in an RDBMS, the consistency that an RDBMS gives us. NoSQL doesn't give us that. But NoSQL is useful in many other scenarios where we are actually using an RDBMS and it's actually slowing our applications. Then database scaling. RDBMS are scaled up by adding hardware processing power. NoSQL is scaled out by spreading the load. So when we are using an RDBMS and we have, for instance, we are running a database and then there is a table in the database and the table goes over to 1 million records or goes to 2 million records, and we need to actually increase the capacity for storing that. We can't actually add in new hardware and spread it over multiple servers. We will actually have to scale up. We will have to increase the server's RAM, increase the server's processing capability, increase the server's storage capability. Whereas when we have a NoSQL database, we can actually add in legacy hardware and we can spread that a single table, a single document repository over multiple servers. This technique is known as sharding in MongoDB, and it's basically there to make the data highly available. Like if even one instance of my document goes down, some other information related to the same document is available on some other server. It will not be the same information, it will be part of that information. Like maybe I have information of 20 users stored per server. If one node goes down, then I'll just be losing 20 users information. It will not be my whole database on its own, right? Here is a example that shows it. Then relational database scaling. At certain point, relational database won't scale anymore. Like we won't be able to scale our relational database after a certain point. Like there is a limit to what we can put in as storage, what we can put in as RAM, or what our server's processing capabilities are. So at one point, this is the number of users that are actually using, and this is the system cost. Now each time as we go across the line, the system cost goes up, maintaining that single server, adding in new hardware, scaling it up to a certain point, and similarly the response time of that server will also go up. Like it will be a single server that is actually serving information to us, right? And we can have multiple instances of the same server running, but we can't actually divide its load to multiple servers. Like if there is a storage, if there is a database that I have created on one server, I can replicate it to multiple servers and divide users using a load balancer, right? But those servers, they will be a replica of each other. I'll have to ship the information from one server to another one.
There are two types of applications, horizontal and vertical. You are talking about only one type.
When we are comparing it to a NoSQL environment, like how Facebook is doing, like how Twitter is doing, Well, if we just take up the single comments part of Facebook, all of that information is scaled out to 40,000 servers or 50,000 servers, and this thing will always be there in the RDBMS. It is never going to be better than this. RDBMS is good for its own purpose, right? NoSQL is good for fetching results, doing the map reduce for me, and handling big data. When we are actually scaling to this size, where we have to scale up so much that our hardware cost goes really up, and we have to actually consider dividing it onto multiple servers, that means we are into a big data problem, right? And when we are into big data problems, we cannot actually fetch that big results from RDBMS. RDBMS is optimized for storage only. It stores our data in an optimized way, and where these NoSQL and our Hadoop based solutions and big data solutions, they are optimized for fetching results. Like Yahoo did a sort over 1 terabyte of data, and it took them to and they added 207 nodes to do that. 10,000 nodes, and it took them 207 seconds. Now achieving that kind of a result over an RDBMS is very tough. Like you'll be needing real big processing machines to do that. And basically RDBMS is built for storage. It's not built for fetching results or doing analytics.
SQL is also one of the RDBMS
systems,
and they also claim that we can sort that much number of business records in a fraction of a second. And if we cannot do it, you can sue us. Why they are claiming?
They actually do it in RAM. They have created an Oracle solution that sits in the RAM and does the processing over there. Now actually purchasing an Oracle based solution versus buying legacy hardware and putting it all together, it's hell of $1,000 cost, like multiplied it to millions. This is my favorite topic. We can go on. In NoSQL, scaling horizontally is possible. With NoSQL, scaling up, down is easy. Supports rapid production ready prototyping, better handling of traffic spikes. This is the same. It's compared to how an RDBMS is handling it and how NoSQL is going to handle it. We can add up multiple nodes. Those nodes will share the traffic, will actually be sharing the load that's coming to them. Thus, it will make the response time of our server, of our application, far better than what an RDBMS is giving us. This is a solution set of companies where NoSQL databases are being used. Google is using them, LinkedIn is using them, Facebook has its own, they developed their own legacy solution, Cassandra. Twitter is using Hadoop, HBase, FlogDB, Cassandra. Netflix, CERN, the only company that's using CouchDB, and we are the other one. So this is a brief history of how NoSQL started off and how it evolved over time period. NoSQL was already there when we had RDBMS solutions, but we were not talking about it a lot because they were object-oriented database solutions. We actually used serialized data and stored that data in the form of serialized arrays into the database. But now what we can do is we use JSON, which is a globally accepted standard at the moment. And they started off with multi-value databases at TRW in 1965. I got this off from somewhere, so don't expect that I'll be answering a lot from here. But the main point is the term NoSQL was reintroduced in 2009, and some NoSQL conferences, NoSQL Matters, NoSQL Now, stuff, and that's pretty much about it.
One of our clients is still working with multi-value DBs.
Wow, it's pretty old, 1965. Okay, when we talk about NoSQL, we talk about the CAP theorem. What this theorem is, it is impossible for a distributed computer system to simultaneously provide all three of the following guarantees: consistency, availability, partition tolerance. Consistency, all nodes see the same data at the same time. Availability, a guarantee that every request receives the response about where it was a successful or failed. Partition tolerance, the system continues to operate despite arbitrary message loss or failure of part of the system. So we can have any two of these. No system at the moment can have all the three options available. A distributed system can satisfy any two of these guarantees at the same time, but not all the three. This was given by Gilbert and Lynch. Second, in other words, CAP can be expressed as if the network is broken, your database won't work. Won't work equals to down or inconsistent. If like your node goes down, that means there is no data, there is no availability of data anymore. Your application is down for that time period, right? In RDBMS, we do not have network partitions. Consistency and availability are achieved. In NoSQL, we want to have partitioning. Need to select either A or C or A. Consistency and availability. We can use either one of them. Either our data can be consistent, like it can be available over all of our nodes, or our data can be available. Now this is very different. Like if we are actually going to achieve consistency, we'll actually be running back into the same problem. We'll be doing transactions, and then we'll be waiting for other nodes to be updated, and we'll be executing we'll be sending back a response once we have that data over there, right? But if we go for availability, our data will be served on whichever node it is available. If it's not available on a node, it will not be served. So either we can make it consistent or we can make it available. It says drop A, accept waiting until data is consistent. Like we don't want availability, we want consistency. So we can wait, our application can keep on waiting until the data is available over there. Or accept getting inconsistent data sometimes. Like data will be forwarded to all of the nodes or will be replicated to all of our nodes, but it is not going to be consistent. We cannot be sure that it is going to be there on node A and it's going to be there on node B as well. Maybe it's part of it is available on node B and the whole data is available on node A. So we can have inconsistent results, but it is going to be available in all times. Visual guide to NoSQL systems. Availability, each client can always read and write. Availability and partition, these are the databases that support this: Dynamo, Voldemort, Tokyo, Cabinet, Kai, Cassandra, SimpleDB, CouchDB, React. I was using this React as well. Consistency and availability, RDBMS, MySQL, Postgre, etc. NoSQL, Aster data. Aster is, I guess, Teradata's solution response to big data solutions. Greenplum, yes, it's I forgot the name of this. EMC. This solution is from EMC. It's also a big name. And then there is Vertica. These are all data warehouse providing companies. And we have consistency. All clients always have the same view of the data. Consistency and partitioning, the databases that support that are Bigtable, Hypertable, HBase, MongoDB, Terrastore, Scalars, BerkeleyDB, MemCacheDB, Redis. Redis is basically a RAM-based database, very fast. Partition tolerance, the system works well despite physical network partitions. Let's move on, it's a very tough topic. This is the basic thing that creates a difference between what a NoSQL database offers and what a traditional RDBMS offers. Scalability and better performance of NoSQL is achieved by sacrificing ACID compatibility. Atomic, consistent, isolated, durable. NoSQL is having base compatibility instead. basically available soft state, eventually consistent. And the eventually consistent part is what we usually hear from our NoSQL databases. Let's go deeper into this. Atomicity, this is what an RDBMS does. Atomicity, all of the operations in the transaction will complete or none will. Consistency, transactions never observe or result in inconsistent data. Isolation, the transaction will behave as if it is the only operation being performed upon the database, that is uncommitted transactions are isolated. Durability, upon completion of the transaction, the operation will not be reversed. For instance, committed transactions are permanent. So we are actually, these are the things that actually make sure that the data is consistent and it's actually reliable. It's not eventually consistent. Even in terms of NoSQL, we use basically available, BA, the first part, use replication and sharding to reduce the likelihood of data unavailability, and use sharding or partitioning the data among many different storage servers to make any remaining failures partial. The result is a system that is always available even if subsets of the data becomes unavailable for short time periods. Right, so this is the first part, basically available. The availability of base is achieved through supporting partial failures without total system failure. For example, if users are partitioned across 5 databases, this is the example that I was giving earlier in the start of the presentation. If users are partitioned across 5 database servers, base design encourages crafting operations in such a way that a user database failure impacts only the 20% of the users on that particular host. This leads to higher perceived availability of the system. Even though a single node is failing, the interface is still operational. This is the example that I gave earlier going into the training. Like we have the data divided among multiple shards, multiple nodes in such a way, like if one of the nodes is not available, our data is not totally lost, or our response is not totally, our application doesn't go down. The part that is available will still be served to the users. So our application is available, it's highly available. Right? That depends. I don't think so. Cluster works in a very different way. This I'm talking about a single document base and dividing it into multiple nodes. Like I can put in 1,000 nodes and I can divide my single document base on it, right? What will happen is, if like 10 of my nodes go down, still the same repository is available to me, and it's divided over multiple hardware, right? When we are using a cluster, we are not actually dividing the table over network. We can't actually achieve that, dividing a single table on top of a whole network. I cannot give 1,000 servers to a single database table, right? Or is there an example over it? I don't think so.
Cluster works the same way. The schema and even the data is exactly the same between two.
That is a replica. Each one of them is a replica of each other.
That is a different thing. You will not be even user को ये नहीं पता होता कि मैं कहाँ जा रहा हूँ. He will be going to a cluster जो क्या लें cluster server है या whatever. उसके back पे क्या है you never know. If one of the servers goes down, you will be getting the servers, but you will never know that the one of the servers is down.
I agree with you.
Getting the exactly same data, or even they can even handle it if there is any transaction going on.
I agree. But what you are actually doing is, आप क्या अचीव कर रहे हैं उससे? आप कर रहे हैं आपने एक डेटाबेस बनाई एक क्यू पर, आपके पास लोड बढ़ गया. अब वो सिंगल डेटाबेस जो है वो हमें रिस्पांस टाइम बढ़ना शुरू हो गया, हमारा हार्डवेयर नहीं सर्व करा. हम लोग उसको क्लस्टर्स में डिवाइड कर देते हैं, मल्टीपल.
क्लस्टर में ये एक चल रहा होगा. अगर आपने 3
सिंगल इंस्टेंस,
3 में अगर आपने इंस्टेंस 3 को कंबाइन करके एक क्लस्टर बनाया हुआ, तो उसमें एक नोड आपको सर्विस दे रहा होगा, बाकी तो बैठे होंगे. They will be available in case of
high availability.
Replicate करें ना,
replicate देखिए concept. अगर आप देखेंगे तकरीबन एक जैसे नहीं, replicate में ये नहीं होता. replicate में आपने एक सर्वर फिजिकल एक जगह रखा हुआ है, सर्वर फिजिकल दूसरी जगह पड़ा हुआ है. इसमें कुछ चीजें हैं, कुछ चीजें उसमें हैं. Depends on how you are replicating it. Like I said, آپ 3 ٹیبل ادھر رکھ سکتے ہیں, 3 ڈفرنٹ ٹیبل ادھر رکھ سکتے ہیں. یو کین ایون ڈیوائڈ اٹ فردر, آپ 3 کالمز یہاں رکھ سکتے ہیں, آپ 3 کالمز وہاں رکھ سکتے ہیں فار اے سنگل ٹیبل. دیٹ از ریپلیکیشن. کلسٹر از ناٹ دیٹ. آپ کے بہائنڈ پہ یہ سرور ہے, اس نے پیچھے سروس دینے کے لیے کیا کیا ہے وہ اینڈ یوزر کو نہیں پتا ہوتا. کلسٹر اس کے بیک پہ ہے, ایک SQL ادھر ہے, ایک ادھر ہے. ان ادھر آپ یہ کہہ سکتے ہو کہ ایک سسٹم میں بھی یہاں پہ, ایک سسٹم میں بھی یہاں میں سیم ڈیٹا یہاں پہ کمٹ ہوگا, ادھر بھی کمٹ ہوگا. لیکن اگر یہ ڈاؤن ہوا ہے, یہ ادھر ہی ہے, آپ کی ریکویسٹ یہاں آ رہی ہے, ادھر نہیں آ
رہی. اچھا, آپ نے اپنے کوشچن کے اندر نا خود ہی آنسر بھی کر لیا اس کا. میں ایک سیکنڈ دوبارہ اس چیز کو ریوزٹ کر لوں. اچھا دیکھیں, آپ نے کیا کہا کہ ڈیٹا اویلیبل ہے ایک نوڈ کے اوپر بھی اور دوسری نوڈ کے اوپر بھی, یا کلسٹر کے اندر جو ملٹیپل جتنے سسٹمز کا میش بنا کے آپ نے کلسٹر بنایا ہے, رائٹ, ان سب کے اوپر ڈیٹا اویلیبل ہے. ہم لوگ ذرا بات ڈفرینٹ کر رہے ہیں. ہم کہتے ہیں کہ یار ہمارے پاس ہائی اویلیبلٹی آرکیٹیکچر کے اوپر آپ بالکل بتا رہے ہو, رائٹ, کہ اگر آپ کی ایک نوڈ چلی جاتی ہے, دوسری نوڈ فوراً سے ماسٹر بن جاتی ہے. ماسٹر ڈاؤن ماسٹر اپ ہوتا ہے, جو نوڈ ماسٹر بنی ہوئی تھی وہ واپس اس کو رول دے دیتی ہے, رائٹ. آئی ایگری ود دیٹ. سیکول کے اندر آپ بالکل اچیو کر سکتے ہو, آپ کسی بھی RDBMS کے ساتھ یہ چیز اچیو کر سکتے ہو. The purpose of NoSQL on the other hand is handling bigger data. ایک دوسرا کہ میرا جو سنگل ڈاکومنٹ ہے وہ اس طرح ڈیوائڈیڈ ہے میرے کلسٹر کے اندر کہ وہ ڈاکومنٹ اٹ سیلف ڈیوائڈیڈ ہے. ٹھیک ہے, میری جو ایگزیکیوشن ہو رہی ہے اس کو جو ہینڈل کر رہی ہیں نوڈز, یا جس نے اس کے اگینسٹ رسپانس دینا ہے, اگر ان میں سے میرا ایک پارٹ آف ڈیٹا چلا جاتا ہے, فار انسٹنس فیس بک کے پاس پاکستان کے اوپر 10 سرورز لگے ہوئے ہیں, رائٹ, ایچ شہر کے لیے ایک اس نے نا ڈیوائڈ کیا ہوا ہے سنگل یوزر کمنٹس کو ہینڈل کرنے کے لیے. اچانک سے آپ کے کمنٹس ڈاؤن ہو جاتے ہیں, کسی ایک ایریا کے ڈاؤن ہو رہے ہوں گے نا, باقی جو پاکستان کے لیے جو یوزرز ہیں نا ان کے لیے جو باقی ڈیٹا اویلیبل ہے, جو باقی نوڈز جو سرو کر رہی ہیں وہ وہیں پہ سرو کر رہی ہوں گے, وہ ایکچولی ڈیٹا یوزرز ان سب کے پاس جا رہے ہیں, ایک کے پاس نہیں جا رہے کسی بھی. ایک چیز. دوسرا ہاں نا, ایک آپ کا ہائی اویلیبلٹی آرکیٹیکچر. دوسرا آپ کے NoSQL ڈیٹا بیسز, ہم کمپیئر نہیں کر سکتے کہ NoSQL اور RDBMS کے درمیان میں کوئی ایسا دیر از ورسز بٹوین دیم, رائٹ. دیٹس لائک کمپیئرنگ کہ میں جاوا یوز کروں, میں .NET یوز کروں, یا میں PHP یوز کر لوں. 3 آف دیم دے آر ریئلی گڈ ان دیئر اون وے, رائٹ. ایک دوسرے کے اوپر لیوریج کسی ایک پوائنٹ پہ لیتی ہے تو دوسرے کے پاس بھی کوئی نہ کوئی بینیفٹ ہو رہا ہوتا ہے. وین وی آر یوزنگ NoSQL ڈیٹابیسز وی آر ایکچولی انشیورنگ کہ ہم لوگوں کے پاس یہ جو ایسڈ ہم نے جہاں پہ امپلیمنٹ نہیں کرنا, رائٹ, جہاں پہ ہم لوگوں کے پاس ڈیٹا اتنا زیادہ ہو گیا کہ ہم لوگوں نے اس کو اتنی زیادہ ملٹیپل نوڈز پہ ڈیوائڈ کرنا ہے کہ جو ہمارا رسپانس ٹائم ہے وہ منیمم ہو جائے. ٹھیک ہے, ایک تو رسپانس ٹائم منیمائز کر لیں, دوسرا ہم اس کے اندر سے ہائیلی اویلیبل کر لیں ڈیٹا اپنا. اب ٹویٹر 2.3 بلین کی ہٹ لیتا ہے ایک دن کے اندر, فار انسٹنس کوئی ایک ہیش ٹیگ چلنا شروع ہو جاتا ہے اور وہ اچانک سے ایک اتنی بڑی ہٹ آتی ہے کہ وہ اس کی ڈیٹا بیس سرورز اس کو سپورٹ کر جاتے ہیں. تو وہ ایکچولی NoSQL کی طرف اس لیے گیا ہے کہ NoSQL کو مینٹین کرنا ان کے لیے کاسٹ افیکٹو ہے. اگر آپ اسی طرح RDBMS سولوشنز لگاتے ہیں تو اس سائز کی ہٹ برداشت کرنے کے لیے جو آپ RDBMS سولوشنز لگائیں گے دے آر گوئنگ ٹو بی ویری ایکسپینسو. ایک کیونکہ لیگیسی ہارڈ ویئر آتا ہے ان کے ساتھ. اگر ہم اوریکل کی بات کرتے ہیں, اوریکل اپنے ریکس لا کے دیتا ہے, اوریکل کے اپنا وہ سارا سولوشنز ہوتے ہیں. ٹھیک ہے, اوریکل کسی وجہ سے اس کو ہینڈل نہیں کر رہا, یا SAP بھی اس کو ہینڈل کرنے کے لیے نہیں تیار بیٹھا ہوا, کیونکہ یہ ویئر ہاؤسنگ کی طرف جاتے ہیں اور دے ٹاک اباؤٹ کولڈ ڈیٹا. وین وی آر ایکچولی ان دا پروڈکشن اسٹیٹ, اور وہاں پہ ہم لوگوں نے NoSQL لگایا ہوا ہے, تو وہ ہمیں اسی طرح ہی رسپانس دے رہا ہے, اسی طرح ہی سب کچھ دے رہا ہے, ڈسپائٹ کہ اس کے اوپر چاہے جتنی مرضی ہٹ آ رہی ہے یا جتنا سائز آف ڈیٹا موجود ہے وہاں پہ. صرف یہ ریزن ہے.